Alrighty, welcome back, boys and girls. It's your main math man, Ms. Shank, coming to you live from Walker Grant Middle School. And in this video, we're going to be working on some multi-step inequalities, but they're going to be very similar to what you did with equations. So we're still going to be using those same steps as always. Just like with equations, we're still going to do distributive property first. We combine like terms next, and then we manipulate the variable to close out the last step. But you want to make sure that you're always having the variable on the left side. So let's actually write that. So we want the variable on the left side, and that way we can match up our inequality symbol and it will point to the right direction. What else do we need? Well, we have our steps. We want the variable on the left side. And also, last idea here, anytime we multiply or divide by a negative, change that inequality symbol. Change the inequality. Let me actually move this up. So change the inequality symbol. Just some ideas to keep in our mind. So, as always, again, we will know that we have this. So I'm going to do that distributive property first. And so what I can do is I can, let me actually move this a little bit further to the right. There we go. What I can do is I can draw that box for our distributive property. Again, on the outside, I'm multiplying 3 times each of the inside terms. So I have positive 3 times a positive 1x and a positive 4. Positive 4. Now after that I do 3 times 1x is going to be positive 3x, and I do 3 times a positive 4 is going to be a positive 12. So now I can rewrite my inequality like this. I would say it's going to be 3x, so I say 3x plus 12 is less than 30. So now I can subtract both sides by 12. I want to get all those like terms on the same side. So I want to get all the constants on one side and all the variables on the other. So I'm going to get and subtract 12 from both sides. And so I have this, I have 3x is going to be less than, 3x is less than 18. Always divide by a coefficient. And so again, that's that last step for manipulate the variable. So I did the distributive property, I combined my like terms. Now I need to manipulate the variable. I need to divide both sides by 3. So divide both sides by 3. And I end up with my value of x is less than 6. So let's write that a little bit better. X is less than 6. So that was my manipulate the variable step. So again, it's multiplicative inverse property. Always make sure you are multiplying by the inverse, and so we're dividing by the coefficient. So now when I go to graph it, again, I have that number line there. I usually number it. I have in the middle my value that I'm working with. I have one below, and so I'd be at 5, and one above would be 7. And so now we're going to say, all right, well, as we're looking at this, is this going to be an open or closed circle, excuse me? Well, since it's no filled in line, we're going to have no filled in circle. So I have a no filled in circle on 6, and we notice, hey, it's pointing to the left, and so I'm going to shade in all of my values to the left. So anything less than 6 could be a solution. So let me actually write that. So any value less than 6 is a solution. So you're just trying to think, okay, what is a possible solution? Well, is 0 a solution? Meaning this. Is this true? Is this true? Is 0 less than 6 with a question mark? Well, you tell me. You better believe it is. And so since it is true, we would say yes, 0 is a solution. If you wanted to check using that Desmos Calculator, it would look something like this. We could type it in exactly as it looks. And so I could say, all right, I have 3x. Actually, let's say parentheses x plus 4. I'll close those parentheses. Now I have my left side of the inequality symbol. I have my right side, and so I'm going to have just 30. I'm saying that whatever value that I have here, I need to make sure that I am saying that whatever value I get for this left-hand side, it has to be less than 30. So when you choose your value, I can say x is going to be equal to, well, we chose a value that's less than 6. So we could say something like, if we let x equal 0, we would say 12 is less than 30, so this is true. If we said something like 4, we have 24 is less than 30, so we know it's good. However, make sure you're seeing since it is strictly less than 6, we would not be able to include 6. And if you notice, that's because it's saying this is equal to, so that symbol would have to be an equal sign if we wanted to try to do that. So we have to be very mindful of what you're typing in and what values you are placing. So any value less than 6 would be a possible answer. So now for the next one, it has the inequality 1/2 times the quantity x. 8x minus 4 plus 7x is greater than or equal to 108. So always break down as follows. It kind of looks like this. Let me actually have this in here and slide this over a little bit further. So something like this. I would say I have the following. I have my distributive property, I have combined like terms, and manipulate the variable. So again, I'm going to do that distributive property first. I take 1/2. What's 1/2 as a decimal? Well, let's see, 1/2 as a decimal is 0.5, so I can take and have 0.5 times each of the terms inside the parentheses. So I put the terms on top, so I'm going to have a positive 8x, so positive 8x, and a negative 4. Multiply each of those, so I take positive 1/2. Let's do it like this. Positive 1/2 is going to be times 8x is positive 4x. I take 0.5 times a negative 4 and get negative 2. So I did my distributive property. And so now I have this. I'm going to have 4x. So I have 4x minus 2 plus 7x is still greater than or equal to 108. Now I need to combine like terms. And so I could say, well, I know that I have a like term of 4x and 7x. And so I can combine those together to be 11x. And then the rest stays the same. So I bring down that minus 2, and I say that's greater than or equal to 108. Still on that combine like term step, we want to get those constants to the other side. So now we're going to do our inverse operations. Again, add 2 to both sides. Add 2 to both sides. Now I have 11x is greater than or equal to 110. So since we have all of our variable terms on the left and all of our constant terms on the right, we know we can do this last step of multiplicative inverse. So I'm going to divide both sides by 11. I divide both sides by 11, and so I have x. Let's have it like this. So I have x is going to be less than or equal to, greater than or equal to, and it's the alligators eating the bigger amount, so greater than or equal to 10. So I say x is going to be greater than or equal to 10. So it's any value greater than or equal to 10. So we would include 10 for this one. So again, closed line or filled in line, filled in circle. So we go to graph it. I'm going to have 9, 10, and 11. And when we go to graph it, and we're going to have that filled in circle on 10. Again, if it was an equal sign, we would just leave it be. But since we have an inequality, we have to shade all the values that are also greater than 10. So we're going to include 10 and all the values that are to the right. So again, make sure that you are matching that inequality symbol to the arrow head on your graph. Again, that only works if that variable is on the left side. So now let's say is 0 a solution? Let's find out. So we can actually check and see. So I can type it in. I can say 1/2 times the quantity. I have, let's have 8x minus 4 parentheses, and then we have plus 7x. And so that's our left side of the inequality. And so we're going to say, well, we need these two lines to be, we need this first line to be greater than or equal to 180, or excuse me, 108. So if we say, if we let x equal 0, do we get that case? Well, we know that -2 is not greater than or equal to 108. And so we would say, no, it is not. So we would say, no, 0 is not a solution. Well, what would be a solution? Well, let's try, what about 5? Is 5 a solution? Well, no, it's not, since 53 is not greater than or equal to 108. What about 13? Well, yes, it is. Again, we said that it has to be any number greater than 10 is what we're trying to plug in for x. And so since 13 is greater than or equal to 10, we could say that our expression on the left-hand side is 141, which is greater than or equal to 108. So we know we are good. So again, any of those values would be possible solutions. So now on the back, it has the inequality like this. And so if you notice, it has variables on both sides. Is there any distributive property? There's no parentheses. So now we need to combine like terms and then manipulate the variable. Since this variable is on both sides, we need to find that lower coefficient. So find lowest or lower coefficient, and add the opposite to both sides. Opposite to both sides. So now, let's check it out. We have the following. We have a -5 and a -3 as the coefficients that we currently have. Excuse me. So when we go to do it, we would say that -5 is the lower coefficient. So that's what we're going to add to both sides. So we add the opposite. So we have plus 5x to both sides. Again, always take it one step at a time. And so now I have on the left side, did we multiply or divide by a negative? We did not, and so the inequality symbol stays the same. On the left, we just have a 10 because the 10 drops down and the 5x's cancel out. And then we have a 2, and then we have a positive 2x. Now we can still get rid of the constant terms. We want to get it to the other side. And so we subtract, we add the opposite to both sides. And so we have on the left side, we have 8 is greater than 2x. Make sure you can divide by coefficients. So we did our combined like terms. We have all the variables on one side and all the constants on the other. And so we divide both sides by 2. And so we say 4 is going to be greater than x. But we need to make sure that we have that variable on the left side. So you could say this would be a possible answer, but you want to make sure you can draw the other way, so that way it's a little bit easier to graph. So you would say or, so you could say or x And now we need to make sure that it is still, that alligator is still eating the correct direction, meaning our 4 still has to be greater than. So we need to say that x is less than 4. So we'd say x is less than 4. So again, these are the same thing. They're saying the same statement, but you want to make sure that you have that variable on the left. That way it is easier to graph. And so now when you get to graph it, again, we can have our value that we're working with in the middle, 1 below and 1 above. Since it's no filled in line, we have no filled in circle, so I have an open circle on 4, and we're going to be shading in values to the left. So any value that is less than 4 is going to be a possible answer. And so would 0 be a solution? You better believe it is. Yes, because 0 is less than 4. So we could say since 0 is less than 4, is true, then it is a solution. It is a possible solution. Again, we can always check and make sure we have it in here. So again, I can check using that Desmos Calculator, type it in exactly as it looks. We have our left side as 10 minus 5x, and we're saying that the left side has to be greater than the right side, which is 2 minus 3x. And so let's say when we plug in for x equals 0, again, we're saying that that left side has to be greater than, so we're saying 10, is 10 greater than 2? It is, and so we know we are correct. And we can try other numbers like, maybe 3. We have it shaded in on there. We're saying that -5 is greater than -7. So that might trip some people up, but we know that it's true since we're looking at that number line. Again, -5 is greater than -7. On this last one, it might look tough, but you know the steps, and so you just follow the staircase up the whole way. First, distributive property, combine like terms, and then manipulate the variable. So I'm going to now take -2 times each of the values inside the parentheses. So I have a positive 1x and a positive 20. Multiply these together, I get -2x, and I have a -40. So I can rewrite by inequality like this. I would say I have -2x minus 40, and everything else stays the same. So I have plus 19 is less than or equal to -19 minus x minus 20. Make sure you can combine like terms on the same side first. And so I'm going to combine -40 and 19, but I'm also on the right side, I can combine -19 and -20. And so when I write this, I would have -2x is, and then subtracted by 21, I have less than or equal to, I have -39 and a -x. Now make sure you're saying I have a -1x. Again, I have a -1x. Again, there's only 1x there, so that's our coefficient. The reason why I'm pointing that out is because we need to have and see, well, we have two variables, or we have variables on both sides, and so I look at the coefficients. We would say, hey, I know that -2 is lower, and so that's what I'm going to add to both sides. So I add 2x to both sides, so plus 2x to both sides. On the left side, I just have a -21 is less than or equal to a -39 plus x. Make sure you get all the constants to the other. And so we add 39 to both sides. Add 39 to both sides. And so we should be just left with our value of 18 is less than or equal to x. Again, make sure your variable is on the left side, and so you need to make sure you can change this inequality the whole way around, but it will still be the same. So we could say this, it could be this answer, or you could say this. You would say x and 18, but you want to make sure that it's still eating the same way. So I'm going to say that the x is going to be larger, and so it has to be greater than. So I'd say any value greater than or equal to 18 is a possible answer. So when you go to graph it, again, I fill in my values, and I can say I have a filled in circle on 18. Again, a filled in line is a filled in circle, and it's any value that is greater than 18, and so we would shade to the right. Does that mean 0 is a solution? Definitely not. And let's actually prove to see how that works. So again, when I type it in, I have -2 times the quantity, and I say x plus 20, and then I close the parentheses and I have plus 19, and that's my left side of the inequality. Then on the right side I have -19 minus x, and I have minus 20. So what we're trying to do is we're trying to say this first line, we want this first line to be less than or equal to this second line. If that's not true, then we know our answer that we type in is not correct. So if we type in x equals 0, we know that, hey, since this value of -21, it should be less than or equal to -39, which it is not, and so we know that x equals 0 is not a solution. However, maybe something like if we typed in x is 20, if x is 20, we'd say, hey, yeah, that first line is less than our second line. So again, when you're using that Desmos calculator, be very mindful of what you are typing in and what you need to have. As always, make sure you go through each step very carefully, and be sure to super slam that subscribe button.